So when we're asking you to find the trig function of an angle, without a calculator, the only angles we can ask you are based on a 30, 60, 90 triangle or a 45, 45, 90 triangle. Without a calculator, they're the only ones we're going to be able to find. So whenever you're doing any trig function of anything at all, you need an x coordinate, a y coordinate, and a radius. So how we're going to do that with these is we're going to base those from one of these triangles by just graphing that angle. The first thing you do is look at your angle and draw me a terminal ray for that angle. The numerator is just a bit bigger than the denominator, so we know we're in quadrant 3. That's from yesterday's lesson. So that's my terminal ray for the angle theta. Don't sketch the angle, don't put this twiddly line, it'll mess up your picture. So now, once we've graphed, draw the terminal ray. Step 2 is link that terminal ray to the x-axis. So put a point on the terminal ray, join it up to the x-axis, and now we've made a reference triangle for this reference angle. The angle is always by the origin. Our reference angle is going to be the reference angle for 4 pi over 3. It's really easy in radians with our special angles. If the denominator is 6, 4, 3, 2, 3, 4, 6, our reference angle is just going to be, it's going to have the same denominator. Now, if you're not thinking in radians yet, pi over 3, by the way, is your 60-degree angle. We're trying to identify one of these angles. So that's going to be 60 degrees. So we know this angle here is 60 degrees. Now, on this picture, we want to find out the x, y, and r coordinates. So label them. On a 30, 60, 90 triangle, this would be the 30. Opposite the 30 is the short side. Opposite the 60, this must be the long leg, and your radius is double the short leg, okay? So what I've been able to do from that picture now, I've been able to identify that my x, my y, and my r are 1, √3, and 2, but that's wrong. Can you see why that's wrong? This was graphing in quadrant 3. And if you're in quadrant 3, any x, y point, the x coordinate, you've gone to the left one. So it's -1. You've gone down √3. So your y is -√3. What I want from this picture is I want to have a triangle with a clearly marked terminal ray and with numbers on all 3 sides. You found your x, y, and r. That's what I'm looking for in your work. Now we can go back and we can actually answer the question. A tangent is simply a ratio of a y divided by an x, and now we have that information here. So our y is -√3, our x is -1, and if you divide a negative by a negative, you end up with a positive. So the tangent of 4 pi over 3 is the square root of 3. Let's look at the secant of 7 pi over 6. For a secant, I'm going to want to have an r over x. Now these things, these ratios with the x's, y's, and r's, you have to memorize those and know those well. But let's do the same process we did last time. Step 1, graph the angle. The angle I'm actually looking at is 7 pi over 6. So that's, again, going to be in quadrant 3, because 7 is a little bit bigger than 6. So that's my terminal ray. Find your reference angle by linking that to the x-axis. Here's my reference angle. This time my reference angle, I don't want an equals there. Reference angle is not the same. My reference angle is pi by 6, which is 30 degrees. So once again, I'm still in a 30, 60, 90 triangle, but in this one, my reference angle was the 60. This time we're using the 30. So when we label it up, it's going to look slightly different. The 30, the side opposite the 30 is 1. The leg opposite the 60 is your long leg. The leg opposite the 90 is your radius. This time, this reference angle here is 30, not 60. So it's the y that's 1 this time. And the x would be √3. And the r would be 2. Don't forget that x is negative and that y is negative because we're in quadrant 3. So this would be, the radius is 2. That's my radius here. Divided by x, here's my x. R over x, 2 over negative √3. Positive divided by a negative is negative. And I want to rationalize that. So multiplying top and bottom by the square root of 3, have 2 times the square root of 3 over 3. That's your answer for the secant. This picture here could be used to find any of the 6 trig functions. We'll just happen to be asked for secant. Right, let's move on and do something else now. Now, on your homework yesterday, you had some problems about quadrantal angles, and I hadn't really covered them in the lesson. So let's talk about those now. Quadrantal angles are angles that are on one of your axes. They're not in a quadrant, they're between quadrants. And let's have a look at, let's just do pi by 2. If I graphed pi by 2, I would graph this. That's my terminal ray. If you try to do what we just did, you graph your terminal ray, put a point on it, link it back to the x-axis, but you always link it with a vertical line. If I link it back, I haven't got a triangle. Please don't do this. Say, well, I have to have a triangle and do that. No. That's wrong. Don't do that. You always link it with a vertical line. So when you have a quadrantal angle, no triangle is possible. You will not draw a triangle. But to find trig functions, remember all you need is an x, y, and an r. We can still pull that out from this picture. Remember that x and y are just a point. So that would be the x, y coordinates of this point. And r is the radius of a circle. So it's as though we've got a circle going through that point, where the length of that line is the radius of the circle. And if you think about it, this point here, it's x is clearly, you're not going left or right at all. It's x is 0, and its y value would be whatever the radius was equal to. So what you can do is you can choose any radius you like. You can draw a circle of any radius you like. But the easiest thing to do is to choose a radius of 1. If the radius of our circle was 1, to get to this point, we're going across 0, your x is 0, and you're going up 1, if the radius was 1. Okay? So your y would be 1. So from that picture, say I wanted to find the tangent of pi by 2. If I was being asked for the tangent of pi by 2, tangent is simply a y divided by an x. From this information here, my y would be 1, my x would be 0. Ooh, that would give me undefined. You can't divide by 0. Okay? The tangent of pi by 2 is undefined. It doesn't exist. Okay? So let's do another one. Let's have a go at trying to find the cosine of 0. Draw a picture. Graph the terminal ray, and for some reason, the angle 0 really upsets people. If I'd said cosine of 2 pi, you wouldn't have had a problem. But a lot of people go, like, where is 0? Well, it's just here. That's 0 angle. Okay? So once you've got your picture, remember what you were trying to pull out is you're trying to pull out an x value, a y value, and an r value. And normally what we do is once we've got our terminal ray, we put a point on it and we link it to the x-axis. But it's already on the x-axis, so no triangle is possible. Okay? But we can pull out the x and y coordinates of that point if we give it a radius. We're going to say the radius can be anything we like. Let's use 1. What would be the x, y coordinates of this point? To get to the point, you've gone across by the radius. So your x is 1, and you haven't gone up at all, so your y is 0. Now I could find any trig function of 0. We've been asked for the cosine. To find a cosine is the ratio of x divided by r. So it's 1 divided by 1, which gives me 1. And hopefully you can see here, it really does not matter. If I'd chosen r is 12, this was 12. This point would have been 12 out to the side. My x would have been 12. My y still would have been 0. My ratio x over r would have simply been 12 divided by 12. It would still be 1. It doesn't matter what value of r you choose, but we kind of choose 1 just because it's easier. Okay? Now you try sine 3 pi over 2. I'll give you about a minute, a bit less than a minute. You do sine 3 pi over 2. So once again, we just graph the angle. Please always do a graph, xy axes, and graph the angle. I want the terminal ray, 3 pi over 2, would be all the way down here. That's my terminal ray. That's actually the angle there. But when you put those curly lines on, particularly as a triangle, it really messes up your drawing. So we tend not to. It's only when we sketch in the angle that we put that on. 3 pi over 2 is here. And what do we want from that? Well, we try to link it to the x-axis. We don't get a reference triangle. But we do get enough information to do an x, y, and an r. We choose a value of r we want. So let's choose r equals 1. And now think about the x, y coordinates of this point. A point down there on a circle of radius 1. Your x, you can see you haven't gone left or right at all. Your x is 0. Your y, you've gone down. So your y is negative, and you've gone down by the radius, so it's negative 1. What did we want this information for? This would help us find any trig function at all. The question was asking us about the sine of 3 pi over 2. Sine is y divided by r. So sine is, our y is negative 1, our radius is 1, so our answer here is negative 1. Sine of 3 pi over 2 is negative 1. Okay, we're not going to, oh, actually, let's do one of these ones on the bottom on this page. Let's do the cosecant of negative 3 pi. So to find the cosecant, I'm going to want a picture, because from out of that graph, I'm going to do a graph. From that graph, I'm going to want to know, for cosecant, I need r over y. This part you have to memorize. How I'm going to get the r and the y is I'm going to come up with x, y, and r values from my graph. So the first thing I have to do is I have to graph the angle theta equals negative 3 pi. Negative 3 pi. Negative 1 pi would take me there, negative 2 pi would take me there, negative 3 pi is going to take me here. Now, do I want all those wibbly wobbly bits on my picture? No. All I want is that terminal ray. So you don't have to draw that sketch of the angle like that. All I need is the terminal ray. put a point on the terminal ray and tell me the x, y coordinates of that point if we define an r. Remember, the radius of a circle, radius is never negative. A radius is always positive. Let's choose a radius of 1. To get to this point xy, we've gone to the left, so our x is negative at distance 1. And we haven't gone up or down at all, so our y is 0. So the cosecant of negative 3 pi is r over y. Look at this information for your r and your y. Our r is 1, our y is 0, and can we divide by 0? Nope, so this would be undefined. This would work for, this picture would work for any angle that finishes on that terminal ray. It would work for positive pi. This would be the cosecant of just pi, which you could call 180 degrees. That would be undefined. It could be for 1, 2, 3, 4. Oh, it could be 4, 5, any negative value. It could be the cosecant, any odd value of pi. We could have 1,003 pi's. It would still finish on this same terminal ray. They would all be coterminal angles. That would be undefined as well. Okay, so I've done that one for you. You try this one now. Try the cosine of 9 pi. Okay, I hope you noticed that it would be that same picture. Here, I can just slide all of this. Ooh, that's not what I meant to do. Slide all of this over here. This picture counts for any odd number of pi. Any odd number of pi, if I did 9 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. Any odd number of pi is over here. Any even number of pi would be over here. So I can use that same picture. Doesn't matter if it's positive or negative on pi. So to find a cosine, I just need x over r. My x coordinate is -1. My radius is 1. So the cosine of 9 pi would simply be -1. Remember to simplify your fraction. Right, let's move on to something different. There was more practice we can do, but we don't need to. You've got enough practice in your homework. So let's try these ones now. On these ones, you really want to write down this question because this is very different. We've been given a point. We haven't been given an angle, we've been given a point. And we're being asked to find 3 trig functions, sine, cosine, tangent, of an angle whose ray, whose terminal ray, that means, passes through the point. So to find any trig function, like find sine theta, cos theta, tan theta, I'm going to need for sine, I'm going to need a y over an r. For cosine, I'm going to need an x over an r. I'm going to need a picture that I can pull out basically from my picture, I want to be able to pull out x equals, y equals, and r equals. And then I can use those to find any trig function whatsoever. So let's just graph what we've been given. The point, -6, 3. 1, 2, 3, 4, 5, 6, up 3. Graph that point. Read the question again. It says, given a point, find a trig value for an angle whose terminal ray passes through that point. Remember, we always want that terminal ray, and what we've been told is the terminal ray passes through that point. So we could build a triangle by linking the point always to the x-axis, never to the y-axis. This would be our reference angle, and theta itself would be this angle here. We don't know what it is. It's unlikely to be 30, 60, or 45 or 90. It's some angle. We don't know what it is, and we don't care. Because all we want is this x, y, and r, and we now have enough information to find it. Because we know in this triangle, our x is -6, and our y is 3. And now we want to find the radius, and we know in a right triangle we could use Pythagoras. Our r squared is going to be our x squared plus y squared. So our r squared is going to be -6 squared is 36, plus y squared, 3 squared is 9. So we know our r squared equals, that's 45. R is going to be the square root of 45. Now simplify that. 45 is actually 9 times 5. So we're looking for the square root of 9 times the square root of 5. Our radius is going to be square root of 9 is 3, 3 square root of 5. And we were given the x, and we were given the y. So now we could find any trig function. Our sine of theta is the y divided by the r. The y is 3. Looking here. And the r is, ooh, look, ooh, yeah, that's ugly. Can I clean that up? Yes, I can. Simplify, divide by 3, divide by 3. So I've got 1 over the square root of 5. And remember, we want to rationalize this. We don't want an irrational number in the denominator. Multiply top and bottom by the square root of 5, and you end up with square root of 5 over 5. I'm not going to do all of these, but if I needed to do the cosine is x over r, so it's this x divided by that r. It can be -6 divided by 3 times the square root of 5. I can divide top and bottom by 3 again, so I'd have -2 over the square root of 5. Rationalize your denominator, -2 times the square root of 5 over 5. That would be your cosine of theta. Did we ever find out what theta was? No, and we didn't care. The question didn't say find the angle. It just said find the sine, cosine, and tangent. We didn't need to know what the angle was, as long as we could draw a picture that gave us the x, the y, and the r. Okay, you try the next one. I'll give you a minute. So we just graphed the point, -4, negative quite a lot down there. All we want is that terminal ray. It's not on an axis, it's in the middle of a quadrant, so we can make it into a triangle. And in that triangle, we know that our x is -4, because we were told that here. We know our y is -7. This is -7, but we don't know the r. We don't know the angle either, but we don't care about the angle. How are we going to find the r? We're going to use r squared equals x squared plus y squared, Pythagoras. So it's going to be 4 squared is 16, -4 squared is 16, plus -7 squared is plus 49. So that's r squared. So our r will be the square root of, that gives me 65. Now we have these 3 bits of information. We can find any of our 6 trig functions as long as you know their ratios. Okay, so what are they? Cosecant is r over y, secant is r over x, and cotangent is x over y. You need to know those. So cosecant r over y would be the square root of 65. I'm looking up here. Divided by the y, which is -7. Oh, can I leave it like that with a negative in the denominator? No, 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 no. A positive divided by a negative is negative. I get negative square root of 65 over 7. That's my answer, okay? And you could do the others as well. This one was nice because it didn't simplify, so we didn't have to do any of this stuff we did on that one. Okay, right, now for something a little bit different from that. Now you've seen that depending on which trig function you're looking at, for the same picture, on this one, the sine was positive, but the cosine was negative. There is a way that's a little bit helpful to help you work out whether you expect a sine in quadrant 2, the sine to be positive, but the cosine to be negative, and you use this. It's a very quick way to do it. It's called ASTC. There's another way of doing it too. What this is telling you, in quadrant 1, x's will always be positive, y's will always be positive, and of course, radius is always positive. Okay. So in quadrant 1, all trig functions, you're looking at your main trig functions, the three you first learnt, sine, cosine, and tangent. That's what this A, S, T, and C stands for. S is for sine, T is for tangent, C is for cosine. And what it's telling you, in quadrant 2, x's are negative and y's are positive. So anything that has a y in it would be positive. The sine is a positive divided by a positive, because the radius is positive, that would be positive. This is telling us sine is positive. Tangent, though, is not positive, because in this, tangent is y divided by x. You'd have a positive divided by a negative. So in quadrant 2, sine is positive, and its reciprocal would also be positive. Its reciprocal is cosecant, which is r over y. That's also, if r is positive and y is positive, that would be positive as well. But the A, S, T, and C, this C here doesn't tell you about cosecant, it only tells you about cosine. Okay? In quadrant 3, x is negative and y is negative. Tangents would be positive because you've got a negative divided by a negative. And it's reciprocal, cotangent. Cotangent would also be positive in quadrant 3. So this is telling us tangents are positive and cotangents. This was telling us sine is positive and cosecants. And in the quadrant 4, x's are always positive, y's are always negative. You graphed any point there. So the cosine would be positive, because cosine is x divided by r, it's a positive, and r is always positive. In quadrant 4, cosines would always be positive, and their reciprocal, secants, would also be positive. Now, there's a way to remember this, to quickly be able to write down the letters in the right order, and that's just with using acronyms. The boring way is all students take calculus. You just do this and say all students take calculus. Well, first of all, that's boring. Secondly, it's not true. All students don't take calculus. This is my favorite one. Angry Santa traumatizes children. It makes me enjoy doing my math when I do that. I go, angry Santa traumatizes children. And it helps me remember which quadrant the different functions are positive in. So let's use it. Let's use angry Santa. This is what the questions could look like. In what quadrants are the following true? Now, what you're going to find is all trig functions are positive in quadrant 1 and in one other quadrant. So all trig functions are positive in two quadrants and negative in the other two. Positive in 2, negative in 2. So reading this question, question number 1, you're being told that the sine of your angle is less than 0. If your sine is negative, one way you could do it is just say, well, sine is y over r, so it's telling you your y's are negative, but you could use angry Santa as well. Say I want signs that are negative. Well, everything is positive here, don't want that one. Sine is positive here, don't want that one. So my answer is traumatized children. Well, obviously that's not the real answer. My answer is those two quadrants. Those are quadrant 3 and quadrant 4. That's the old-fashioned way of writing it. If you just want to write quadrant 3 and quadrant 4, that's fine, as long as you would recognize those if you're given them in the text. Okay, the other way you could do it is you could just say sine is y over r. R is always positive, where a y is negative in quadrants 3 and 4. It's a little easier that way sometimes. Okay, question 2. We're being told here that the tangent is greater than 0. If the tangent is greater than 0, I'm looking for tangent being positive. All of them are positive in quadrant 1. Only sine and its reciprocal cosecant are positive in quadrant 2, so I don't want that one. Tangent is positive here, and that's what I'm looking for. And cosines are positive here, but tangents would be negative. So my answer here would be quadrant 1 and quadrant 3. Not going to do the third part of that. Let's have a look at this. As I said, every single trig function is positive in 2 quadrants and negative in 2 others. So what quadrant would I be lying if I'm told that sine is greater than 0? So that's telling me I'm looking for sine being positive. My y's would be positive. And where would cotangent be negative? That was a bit more difficult. 2 different ways of doing it. You could use angry Santa if you like, but some people don't like this. Angry Santa, sine is positive. Sine is, all of them are positive in quadrant 1. Sine is positive in quadrant 2. So sine would not be negative in these 2. Sine is positive in quadrants 1 and 2. Now have to look at this other piece of information. My cotangent of the angle is less than 0. So that's telling me that cotangent is negative. This ASTC doesn't tell me about cotangent, it just tells me about sine, tangent, and cosine. If cotangent is negative, that's a tangent upside down. It would also tell me that tangent is negative. So I want the quadrants where tangent is negative. Well, in quadrant 1, everything is positive, so tangent would not be negative. I don't want that one. Tangent would be negative in this quadrant. In quadrant 3, tangents would be positive. I wouldn't want that one. Tangent would be negative in quadrant 4, but I don't want this one because it wasn't true for the sine. Cotangent and tangent are both negative in quadrants 2 and 4, but where do these 2 overlap? Quadrant 2, that's my answer. You could have done this simply by looking at positives and negatives. You could say sine is y over r, and if it's positive, greater than 0, where a y is positive, these 2. And then cotangent is x over y. And if a cotangent is negative, either the x is negative or the y is negative. You can actually do the whole thing. Instead of using ASTC, you can just put indications whether x and y coordinates are positive or negative in each quadrant. In quadrant 1, everything is positive. Quadrant 2, x's are negative, y's are positive. In quadrant 3, both x and y are negative. And in quadrant 4, x's would be positive, and they're going down, so y's would be negative. And let's go through question 4 again, using this method instead of angry Santa. If sine is positive, it means my y must be positive because r's are always positive. So I want the ones where y is positive. I want this one and this one. Don't want those. To work out if cotangent is negative, to get x divided by y to be negative, either x is negative or y is negative, but not both. So this would be good, and this would be good, but not that because they're both negative, and not this because neither of them are negative. So this is again going to leave me with the answer of quadrant 2. You decide which way you prefer doing it, using angry Santa, traumatized as children, or just looking at the x's and y's. This way is probably better. I just like saying angry Santa, I think. Okay, you have a go at number 5. I'm going to do it this way this time. The question is telling me secant is negative. Secant of an angle is r divided by x, and if it's negative, x is negative. X is negative here and here, not here. Then I'm being told that cosecant is greater than 0. I'm being told that cosecant, which is r over y, is positive, and r is always positive, so y must be positive. Y is positive here and here, not there. So what am I left with? I'm left with that quadrant there. Right, these questions get a lot more interesting. Someone's disappeared. That was a bad idea. Okay, let's do this top question here. Write down that information. This is quite a long question. There's a lot to think about for this. The question sounds simple. Find the secant of theta, okay? But we've been given all sorts of information. We know that the tangent of theta is negative 3 over 2, and that the sine of theta is greater than 0. The sine is positive. So keep an eye on where we're trying to go. The question basically is asking us for the secant of theta. And so this is going to be the very last thing we're going to do. To find the secant of theta, we don't need to know what the angle is, as long as we know the ratio. Secant is the ratio of r over x. If I can come up with somewhere r equals something, x equals something, and I'll probably find the y as well, but if I can find this information, then I can know the secant. I don't need to know the angle. It doesn't have to be a 30, 60, 90 or a 45, 45, 90, as long as I can come up with that r, x, and y. So what information have I been given that will help me? I've been given that the tangent of theta, which I know is a y divided by an x, is negative 3 over 2. So I know that my y is something to do with 3, and my x is something to do with 2, but one of them must be negative, but I don't know which one. So let's use angry Santa or all that plus, plus, minus, minus stuff and work out where tangents are negative. Tangents are positive here and here. So this is telling me, the fact that this is negative is telling me I'm either in quadrant 2 or quadrant 4. That's not enough information. The thing I'm going to have to use is this piece of information. If sine is positive, I must have been in quadrant 1 or quadrant 2. I'm not in quadrant 1. So I must be in quadrant 2. Okay? Wow, I'm in quadrant 2, great. What am I going to do with that? Draw a terminal ray into quadrant 2. Turn it into a triangle by linking it to the x-axis. This is a picture of theta. I don't know what theta is, and I don't care. All I need is an x, y, and an r. Now I knew from what I was given here that my y was something to do with 3 and my x was something to do with 2. So put those on and stop for a minute and realize, which one's negative? I'm in quadrant 2, it's my x. My x is negative, my y is positive. I need to know the r still though. So how am I going to find that r? Just use Pythagoras. X squared plus y squared equals r squared. X squared would be negative 2 times negative 2 is positive 4. Y squared, 3 times 3 is 9. So that gives me my radius squared. My radius squared is 13. So my radius is the square root of 13. And finally, I can answer the question. The radius secant of theta is the r, square root of 13, divided by the x, negative 2. Ooh, I can't leave it like that. You can't leave a negative inside the fraction. A positive divided by a negative is a negative, square root of 13 over 2. Okay, there we go. We could use that same picture to find the cosine, the cotangent, the cosecant, anything based on that same picture. Okay, any questions at this point? We're actually done now and you should be able to do your homework, but does anyone have any questions?